All right, so today we're going to look at parts of circles. So first and foremost, remember a circle is a collection of points that are equidistant from a point, from one point. Equidistant meaning they are the same exact distance from one point. That point would be here in the middle. So the first part of the circle we're looking at is the circle as a whole. So this is a circle, collection of points that are equidistant from one point. Well, that one point is right here. We call that one point the center. So, for example, I could call this, say, C. And so point C would be the center of the circle. So point C is the center. Okay. Well, we actually know the name of the circle based off of the center. So we would say that this is circle C. Okay. So circle with a dot in the middle, and you write down what the center is. So circle C, because the center is point C. All right. So this is our circle. It's a collection of points that are equidistant from one point. Well, what is that distance? That distance from the center to a point on the circle is known as a radius. So this is known as a radius. So this would be BC. So BC would be our radius. Okay. All right. So many of you probably have heard these terms before. You probably heard of a diameter as well. So let's talk about a diameter. Okay. So before we do that, let's define what a diameter actually is. It's a special case of a chord. So a chord goes from one point on the circle to another one. So it's a line segment going from one point on the circle to another one. So I'm going to call this, say, E, and let's call this G. And so a line segment EG is a chord. Okay. Well, if I took my point E and I went straight across through the center to another point on the circle, let's call that point D, I will have then that DE is a diameter. Well, you just said that was called a chord. It is. A chord goes from one point on the circle to another. A line segment going from one point on the circle to another. That's what we just drew here as well. The only difference is that this is going through the center. So the diameter will go through the center of the circle. So it goes from one point on the circle to another through the center. A line segment going from one point on the circle to another, traveling through the center. That is a diameter. And it turns out a diameter is really just two radii. Radii is the plural of radius. Well, why is that? Well, a radius is defined as going from the center to one point on the circle. And so you do that twice, don't you? In order to make the diameter? Yes, you do. Okay. So that is another part of the circle. So there are three more pieces that we'll look at. So the first one is actually how a chord is formed. So a chord itself is formed by a line intersecting the circle at 2 points. So that line that intersects the circle at 2 points is known as a secant line. Okay, so a secant line. So I'm going to erase our center, which was point C, the name of our circle, which is circle C because it's named after the center. Our radius is BC. We have another one now at DC and at EC. A chord is EG. We have another one at ED. And then DE is a diameter. So let's erase that so we can define our secant line. So our secant line is line EG. So line EG is a secant line. Okay, so a secant line is a line that intersects the circle at exactly 2 points. Okay, well, we also have another line, and I'll draw it here. Put H here. So this line here intersects the circle at exactly 1 point. Okay, so if it intersects the circle at exactly 1 point, it's known as a tangent line. So line HE is a tangent line. And the point in which it is tangent, or the point in which it intersects the circle, that one point, is known as the point of tangency. So point E will be the point of tangency. Okay. Well, have you heard the term tangent before? You have, when we talked about triangles. And actually, the name of that function within triangles comes from circles, actually. So what actually happens is if you draw a radius to the point of tangency, and if you were to then make a connection, say, with somewhere else on the line, like so, this radius with that point of tangency and that tangent line will always form a right angle, always. Therefore, this angle will be the tangent of this angle will be equal to this length divided by the radius, or the tangent of this angle will be the radius divided by that length. So therefore, because there's a tangent involved, they call that tangent. Okay, so just kind of bringing in a little bit of stuff that you've already heard of before and where it actually comes from. In fact, secant, you may or may not remember, but secant is also a different form of cosine. It's the inverse of cosine. And this is actually where we get that idea from as well. Okay, so these are the parts of a circle based off of points and points and lines and line segments. Well, there are actually three other things that I want to look at. Okay, so let's look at those. So I'm going to pause. Okay, I'm going to erase our circle and our information here. Just three more things that I want to take a look at. So let's draw our circle first. Okay. So the first thing I want to look at is drawing of this circle. So as we move around it, this is called an arc. So an arc is this curve around a circle. Okay, it's called an arc. Okay, ARC. So the reason that's important is because an arc would be any piece of this. So if I just say go from here to here, that is an arc. Okay, an arc could go 180 degrees around, and it would be called a semicircle. So 180-degree arc is a semicircle. Okay. If it's less than 180, it's known as a minor arc. And if it's greater than 180, it's a major arc. Okay. And those are named and defined based off of the points that make up the arc. For example, if that's A, that's B, and that's C, and let's call this D over here. Let's say AC is the diameter, so it goes through the center. If I were to say that, what I end up having is that AB is a minor arc, ABC would be a semicircle because it would go halfway across or halfway around the circle, and ABD or ACD would be a major arc because it goes from more than half of the circle, so more than 180 degrees. If you didn't know, a circle is 360 degrees in total. Okay, so that is an arc. Well, an arc is very important when talking about the next two things. So from arc CD, if I also drew a radius, I drew a radius from point O to point D, what would I form? Well, this here would be known as a sector. And so a sector would be like taking out a slice of the circle as if it was like a pie or a pizza. Right? So that would be a sector. And this area of the circle is a exact portion of it, and it's proportional to the angle that's formed. And so it's very powerful, actually, And we'll look at that a lot later. But we have to understand what this arc is in order to understand what a sector is, as you can see, because it's formed by the arc and two radii. Now, there's one other thing that is also important that we'll look at. And so what I'm going to do is I'm going to go from point B to C. And so therefore, that is a chord, as we discussed earlier. Let's do that in black. Might be a little easier to see. Okay. So that is a chord, BC, because it goes from one point on a circle to another. Well, what we just created is known as a segment. So a segment. Okay. So a segment of the circle. So a segment is as if you take a chord and you just cut across a circle. It's formed by an arc and a chord. And so that's a segment. That is very important because if I wanted to find out information about the segment, first I'd have to realize that, hey, if I were to draw from B to O and make another radius, this really is a sector just with a piece cut out of it. And this piece here is a triangle. This looks almost actually like it was a snow cone, kind of in a way. And then you just only are talking about the ice part on top of the cone. Or like an ice cream cone. You're only looking at the ice cream that's sticking out. You're not worried about the ice cream that's inside of the cone. Right? But do we know anything about triangles? At this point, yes, we do. And because we do, if we knew what the sector was, all we have to do is subtract the triangle. And hey, we know the segment. That's cool, right? All right. So those are the other three parts of the circle that are important for us to understand and know. So we have our center of the circle, which also tells us the name of our circle. The center is the point in the middle of the circle being the collection of all points that are equidistant from the center. That distance from the center to a point on a circle is known as the radius. Going from a point on the circle through the center to another point in one line segment is known as the diameter. The diameter is a special type of chord, which is going from one point on a circle to another in a line segment. That chord is a part of a line that intersects the circle at exactly 2 points. That's known as a secant line. If a line were to intersect the circle at exactly 1 point, it would be known as a tangent line, and it would intersect the circle at what's known as the point of tangency. And as we've seen, we have our arcs, which are the curved portions of the circle. The whole circle itself is one arc. We have the minor arcs, which are less than 180. We have the semicircles, which are 180. We have major arcs, which are more than 180. From these arcs, we can bound it with radii, and we form sectors. And if we take a chord and cut through a sector, we get segments. And those are our parts of circles. We're going to look at these terms and use these terms and definitions a lot more when finding different measurements of lengths, angles, arcs within a circle. So let's have some fun. See you soon.